All right, guys, this is on your ALEKS. Oops, that's a highlighter. Sorry. This is on your ALEKS online homework on the supplemental topics. So this is the Venn/tree diagram section. Okay? And I wanted to help because this question was asked in class, and it says to use Bayes' theorem, but that's not required. I don't know why it's in the tree diagram section and telling you to use something we've never discussed. This is a tree diagram problem. It says the percentage of people in the population who have a certain disease is 34%. Of people who have the disease, it reports 6% of them do not have it. Of people who do not have the disease, it reports 8% of them do have it. So right now we're going to ignore the rest of this and we're going to go ahead and draw a tree diagram of the situation. So we either have the disease or we do not, right? And then the test is either it reports a yes or it does not. The disease reports a yes or it does not. Excuse me, not the disease. The test reports a yes or it does not. So it says 34% of people have the disease. So that means that this branch would have a 0.34 and its opposing branch would have a 0.66. That's 1 minus 0.34. And then I keep reading. It says of the people who do have the disease, it says 6% of them do not have it. So that means 6% have the disease, but it doesn't say they do. It gives them a no. That means that the other 94% have the disease and the test gives them a yes. Now on the second branch down, it says of the people who do not have the disease, it says 8% of them do. So it's accidentally giving them a false positive. That means that the other 92% of people who don't have the disease get an accurate result from the test. So then we want to think about the end result of each of these branches. These are people who have the disease and got a yes. These people have the disease and didn't get a yes. These people don't have the disease and got a yes. And these people don't have the disease and didn't get a yes. So we would multiply the pairs of numbers down the branches. So the first branch would be 0.34 times 0.94. And we would get 0.3196. And then I do 0.34 times 0.06. And I'd get 0.0204. And then I go down to the second set of branches. 0.66 times 0.08. That's 0.0528. And then we go to the final branch, 0.66 times 0.92. And that's 0.6072. So right now we've got our entire tree filled out. Now I can finally read the question, which is also worded absolutely terribly, but we can go ahead and read it. Okay? I'm trying to change the color of my highlighter and it does not want me to do it. All right, that's what I want. Okay. So for the question it says, suppose that a person takes the test and it reports they have the disease. Okay. Just to be clear, that says, given a yes, right? It's saying that it says they do have the disease. Then it says, compute the probability that the person does indeed have the disease. So it says, given they have a yes, what is the probability they do have the disease? So that would look like this. The probability they have the disease given they said yes. And based on our formula, that means in the numerator, they have the disease and the test said they did. but we have to divide by everyone who got a yes. So if we go back to our regular marker color, we know that that means the probability that they have the disease given they got a yes would be line 1, that's 0.3196, divided by, and then in this denominator I have to add 0.3196 plus the other probability that I got a yes on the test, which is 0.0528. So that would be line 1 and line 3 of my diagram. Those are the two lines in the diagram where it says somebody did test positive for this disease. Then I would add those two together to get my final answer, which I'm doing right now. And I would end up with the probability of disease given yes is 0.3196 over 0.3724, which is, I'm going to round this to 4 decimal places, 0.8582. So the probability that somebody has the disease given they got a positive test result is 0.8582. I truly hope this helps you with this homework problem. Good luck. You got this.